If we assume that a relationship is linear when in reality it is not linear, then we have a problem of a misspecified model. And a misspecified model, the conceptual definition of that, is that my theory about how constructs are related to one another is not reflective of how they're related in reality. Conversely, a properly specified model is that when my theory about how constructs are related is reflective of how they're related in reality. Okay, so this is just a kind of a humorous example that I like to use. I think I've said it before that we assume that if one glass of wine is a good thing, then more must be better. And probably we know from common sense that that's not the case, that there's diminishing returns and then possibly even detriments as we move up the scale on the predictor, which is number of glasses of wine. So misspecification can take on several forms. The first is that, again, like I just said, we assume that there's a linear relationship between x and y when in reality it's not. We can assume that there's a relationship between x and y and there's no moderator, but in reality there's a moderator that impacts that relationship. There's a third variable that changes the direction or the strength of that association. So if we leave out the moderator that really is there, we have a misspecified model technically. Same thing with a mediator. If we believe that there's a relationship between x and y, and furthermore that x has a direct effect on y, but in reality x is changing something else, and that's the thing that's really changing the dV, then we have a misspecified model. So if we leave that mediator out. And finally, we may make causation inferences that aren't warranted and have a misspecified model. So we assume that, again, our IV has a direct effect on the dV, but in reality, the dV is impacting the IV, or there's a cyclical effect, or a reciprocal, I should say, impact, causal impact. And furthermore, there could be another variable, a z variable, let's call it, that is causing both x and y. And so x and y, there's no causal link between x and y. Really, it's z that's causing both of them. So we'll get into more examples of this later in the class, but suffice it to say that there's several ways that we can misspecify a model, and oftentimes we do. So we just are trying to get as close as we can for our model of variables to be matching how the variables are behaving, so to speak, in reality, which we don't have direct access to, but we are trying to improve and refine our theories so that our models will be more and more properly specified.